Last but not least, in Unit 9, we have basically the distance formula. Think about conceptually what's happening here. I have 2 points in the coordinate plane. One is at the point -2, 6, and the other one is the point 6, 10. And I want to find the distance between those 2 points. So I want to find the length of that line segment. I can create a right triangle so that that becomes the hypotenuse of the right triangle. Well, the distance between this point and this point, it's just the horizontal distance between these 2 points, so it's the distance between -2 and +6, which is 8. This is the vertical distance between those 2 points, so it's the distance between 6 and 10, which is 4. So 8 squared plus 4 squared equals d squared, which means d is the square root of 8 squared plus 4 squared, which means d is the square root of 64 plus 16 is 80. But then I have to go and look, and 80 has a perfect square in it. 16 goes into 80 5 times. So I end up with 4 times the square root of 5 for the distance. So the distance here, square root of, well, the distance between my x's, between 5 and -5, is 10. The distance between my y's, -3 and +9, is 12. So it ends up being the square root of 144 plus 100 is 244. And now, I know 4 goes in there. See, I don't necessarily always know the largest perfect square. I'm going to see if it's divisible by 16, because I know it's divisible by 4. It's not divisible by 16, so it is divisible by 4. 244 divided by 4 is 61. So I have the square root of 4 times the square root of 61. There are no perfect squares other than 1 that go into 61. So d is 2 times the square root of 61 when I simplify my radical.